Welcome to the statistics learning session. Today we'll be talking about CDF and empirical CDF. This is basically a chi-square test for two modalities. We're gonna stop whatever we were discussing last time, and we'll just move on to a continuous distribution. Though some of those tests still apply discrete distribution, but they are really tailored. Now, CDF, cumulative distribution function. Can can you tell me? Just think about it. Can you just think what do you think the cumulative distribution function is? CDF of a random variable x is denoted by ft and is defined as a probability that x takes on a value less than or equal to t. That is, that is, if you say if you say this is equal to this, probability of x taking value less than or equal to t. Now, what we are doing here is that what we're doing here is that the CDF that's the CDF. Now, theoretically, how do we define CDF? How do you define the CDF theoretically? Theoretically, we can define CDF as a function of indicator variable. What I mean is, let's let there be indicator variable I, and let x be a less or equal to t. And if it is equal to t, then it's 1, else it is 0. Now, what we can say is that function ft is equal to expectation of this indicator variable I, which is less or equal to 1. This is expectation of that. That's the theoretical definition of a CDF. Now, what is empirical CDF? Think about it for a few seconds. Empirical CDF is something that's calculated using the sample data. Now, let's say we have a ID of random variables from x1 to xn. Let's say that, and we have this random variables here, and we take a average of the indicator functions of these random variables. That is, these are random variables, and we'll take indicator function of that, and we're going to average that from I1 to In. And after we do that, we'll just compute averages by summing up all the values of x and divided by n. If we do that, then we'll get the CDF, the empirical CDF, that is for variable x. Now, empirical CDF is essentially an estimator that replaces theoretical expectation in a CDF with average from sample data. So let me summarize what we learned today. Empirical CDF, that is Fn, is a non-parametric estimator of a true function CDF. It's calculated by averaging the indicator functions across sample, which allows it to estimate probability distribution of any given set of data. It's universally applicable because any distribution has a CDF that can be replaced by an average. It's like using a statistical hammer to approximate the theoretical concept with something tangible and computable from data you have. So that's all for today. I'll see you next learning session. Thank you so much. Have a nice day.